So guys, write down the heading: gravitational potential. What is gravitational potential energy? What is gravitational potential energy? The potential energy by virtue of the gravitational pull of Earth is basically what? The gravitational potential energy. Okay. So basically, what is the formula for this potential energy? The big formula we'll discuss in the chapter gravitation. The small formula we'll discuss now. The potential energy of this, for example, suppose this is ground level. This is ground level where we generally this is considered as the reference. And I told you in the reference case always the potential energy will be zero. So let's say this is your reference initial point reference, and the reference potential energy is zero. And if I have a block, let's say whatever block is there, I want to lift this block to a height h above the ground. So basically from here I want to do it over here, right? I want to move this block over here. This height is very very small as compared to the radius of Earth. And this height is very small. Like for example, radius of Earth is how much? Radius of how Earth is approximately 600 and 400 kilometers, 6,400 kilometers. So when this height will be 5 meter, 10 meter, 100 meter, 2 kilometer. Are you getting my point? Till that we'll be using some other formula. So what is gravitational potential energy? It is the work done by an external agent to okay. So basically it is the work done to bring it from, let's say this was the reference point A. So from point A to B, whatever work I'll do, whatever work will be done by external agent, that will be basically your that will be basically your potential energy of this particular point. So please remember, for example, what all forces are acting over here in this case? What all forces are acting over here? The force which is acting over here is mg. Mg is trying to, gravity is trying to pull it, right? But I don't want this block from, going in the direction of mg. I want this block to go against the direction of gravity. So for that, I'll apply an external force. Yes or no? So this external force shall be approximately equal to mg. Slightly greater. I told you in the last classes, whenever I want to move an object in particular, then in particular direction, then one force should be greater than other by a very slight amount. Slightly greater than mg. If it will be slightly greater than mg, then only this will be moving slowly against the gravity to a height. So in this case, whatever work is done by the external agent, which is nothing but what? The negative or work done by conservative force, if you want. है So whatever you want to find out. If you want to find out this, well and good. If you want to find out this, well and good. This is defined as your potential energy of point, or basically this is your change in potential. This will be UF minus UI will be equals to the external agent work done, and this will be equals to what is the external agent? See, F external. What is the displacement? The displacement is H, and what is the angle? Cos 0. Can you see F external was acting upwards and the displacement is also upwards? Hence, cos 0 as F external, and the displacement is in the same. Clear? So when this happens, then F external, I told you F external is approximately equals to mg. This will be m into t. This will be h. Cos 0 will be 1. Initial reference is 0. So the final potential energy of point B is m into. Okay. Please write. Please write down. Guys, whenever you're done, just tell me. ये बंद कर दे. हाँ, देख लो. पंखा बंद करके आवाज आ रही है.
Yes, sir.
Done? Okay. So the potential energy of this particular point B. Always remember. Suppose if just remember it like this. Note the potential energy of a point, or basically of an object of mass m at a height h above the reference, h above the reference is equal to m. Okay, please remember height h above. This is very important. Okay, because whenever we talk above the reference point, then reference के ऊपर ही होगा, है ना, against the direction of gravity. So for example, suppose if this is ground level, and if I have one block of mass 2 kg at a height of 2 meter above the ground, and there is one more block of height of mass 5 kg, and this is 4 meter. Can you calculate the difference in the potential energy of both the guys? Can you please calculate the difference in potential energy of both the objects? And take G as 10 meter per second square. हो जाएगा? I think it's an easy question. So basically potential energy of this object and this object. Potential energy of object A will be twice of m. That's basically m2, and then g will be 10, and what is the height? 2 meters. Similarly, potential of point B, potential energy of point B will be m into g So I think you are able to do this. 5 per 20, 20 is, this is 200 joules. Energy of E will be, this will be 40 joules. And the difference in the potential energy is 100. I think it is easy, right? Is this clear, guys? Okay. The first, this one is easy. Always remember. Now, the second point of note, the potential energy of a point below the reference will be negative. Will be negative. For example, suppose if this is the reference and I have two objects, one object is over here and one object is over here. Let's say this is B and let's say this is A. So can you see over here, this G is acting in this direction, and can you see point B is lying below the reference? So please remember this, if this is H2, this is M1 and this is M2. So initial, you will write A as plus of M1G into H1, and you will write B as minus. Why minus? Because it is below the reference. Okay, when you will be carrying it down the reference point, then you need to do work against the gravity. Then this is चालू करो.
Yes, sir.
Okay, so I'm giving you one more point, one more question. Suppose a pendulum bob is like this. Okay, a pendulum bob is like this. The length of the pendulum is L. The mass of this bob is M. If I move this pendulum bob to an angle theta, if I move this pendulum bob to an angle theta, then tell me what is the change in the potential energy? Fine. Is apply logics, tell me. Done, guys? Go ahead and declare go.
Yes, sir.
So what's the answer, Parinita?
I'm not sure. MGL into 1 minus cos
Is correct.
theta.
It is correct. So basically, what will you do? You choose this as the reference point. And can you see over here this? If I can just find out what is this height, then I can automatically get what? My potential energy, right? Yes or no? So basically, what will I do? I'll just find out this h. And for this, I just have to draw a triangle. Can you see? This is the L from O, let's say O to A, then O to B, it will be a part of a circle, right? Yes or no, guys? If I drop a perpendicular from B on this line OA, let's say at point M, so basically this is your H, right? This is theta, this is H. What is this OB? This will be L. So can you see one triangle getting formed? Triangle OMB. This will be theta, this will be L, and if this whole thing was L, this will be L minus H. So L minus H. So I think I can do it now. Cos theta will be equals to L minus H upon L, which is basically 1 minus H upon L. So from here I can solve H upon L will be 1 minus cos theta, and from here H will be equals to L into 1 minus cos. Is this clear? So now you got what H. And now what is the change in the potential energy? See, A point you have chosen as the reference. So UB minus UA will be basically what? The change in potential energy, and this will be equals to M into G. It will be equals to M into G into L into 1 minus cos. So basically that is the change in potential energy, and that's the answer to your question. Please put it up. Done?
Yes, sir.
Hello Nicolin, what happened?
So my computer shut down.
Happens. Even sometimes I forgot to turn the switch on for the charger, and after 45 minutes it goes, batteries goes down. You know, always अच्छा हाँ, note, एक very important note. Suppose in place of this bob, if generally you consider this bob as what? It's a point object, right? If in place of this bob, if it was a sphere, then that sphere is a uniformly shaped object. Right? So always remember, whenever you have a uniformly distributed mass, then you can consider it as a point object. You can consider all of its mass considered at a specific point, which is called as center of gravity or center of mass. Okay, you can assume all the gravity acting at a single point. That point is basically called the center of gravity. Right or wrong? So we'll have this chapter later on. Sure. अब I'll introduce you to something called as small element method, है ना? See this example very carefully. The example which we are doing is very important. Suppose there is a rod which is placed vertically, standing on the ground, vertically, like in vertical direction on the ground. Okay, this is a uniform rod, mass m, and length is l. This length of the rod is how much? L, and the mass of the rod is capital. Now the question is, I'll write the question because it's the first time you will be encountering small element method in all. The uniform rod of mass capital M and length L is vertically upright on a horizontal surface. On a horizontal surface. As shown, assume potential energy at the base of the rod. Where is the base of the rod? Let's say at point A. Determine of the whole rod. So basically, you need to find out the potential energy of the whole rod. How will you do this question? Anyone would like to think in this? Just think on this and just give me 2 minutes. I'll be back. Yes, how will you do it? See, it is done using something called a small element method. What is this small element method? We'll see. See, where do we use this small element method? Symmetrical or when a physical quantity varies with other physical quantities. Right? For example, here what do you want to calculate? Guys, I need your participation over here. Here, what do you need to calculate? You need to calculate the potential energy of this rod, but we know potential energy depends upon height. Yes or no? Yes or no, guys?
Yes, sir.
So here potential energy depends upon height. And a potential energy formula is U equals to mgh, right? So here potential energy depends on height. So as you go up, the potential energy of that point will increase, right? So suppose if I break this rod into many small pieces. So suppose if I break this rod into, let's say, 1, 2, 3, 4, many countless number of small pieces, and I take this element. So can you see this element is, let's say, at height h1. So it will have a different potential energy. This element, let's say it is at height h2. Are you getting my point? This element is at height h2. This element is at height h3. Are you getting my point, guys? So can you see for different elements the height is different. Also, do you know the mass of this element? Right? You don't even know the mass of this element. So what do we do? we use small element method in this particular. Okay. So what will we do? First thing, do you remember when I taught you differentiation integration? I told you about this. Whenever you will have a rod, if I divide that rod into many small pieces, then this process is called as differentiation, right? So basically, what will you do? You will differentiate this rod into many number of pieces, and you will select a small element on a random list. So basically, I have selected this small element. Let us consider a small element of mass. How much? Can you see the mass of the whole rod was capital M? Since I divided into small m, then the mass of this small element will become dm. Can you see dm? D means small, if you remember. Differentiation, integration, D means small. Differentiation, right? Or differential mass, we call it. Differential mass or small mass. So the mass of this is dm. And let's say the length of this thing, let's say how much, what shall be the length? The length is, let's say, dl. Or in spite of naming it dl, let's name the length as dy, because it is along y-axis. No? So dy, so length dy at a height y above the ground. So at a height y, there is a small element of width dy. See, this small element method is not something which anyone can teach. It's just learnt by practicing it very much. Following the steps again and again, the same steps will be there. Okay. So basically, I have considered this small element at this height y and length of this thing is d, and length of this thing is d pi. So we have considered this. Now, can you now it's a point object, right? Hello, is it a point object? It's a very
Yes,
small
sir.
object, right? So it can be considered as a point object. So can anyone tell me what will be the potential energy of this small element? The potential energy will be equals to what? The mass of this element m into g into what is the height of this element above the ground? What is the height? Y, right? Yes or no? Can you see this is mass g into h, m into g into h. I am using the same formula, but I am not using it for the whole rod. I am using it just for the small element. Okay, I am using formula for potential energy for just the small element. Okay, we are using the formula just for the small element, not for the whole rod, because for the whole rod it was different, right? So that's why we are using this. Now what to do? If I can just know what is this dm, then my purpose will be solved. What will be this dm? The mass dm will be equals to the mass of the small element. But I'll give you one example. Okay, suppose guys there is a rod of a length 5 meter. Okay, and the mass of this is 10 kg. I want I have cut this 5 meter into two small parts. This is 2 meter length, this is 3 meter length. Can you tell me what is the mass of this and this? Can anyone tell me what is the mass of 2 meter part and what is the mass of 3 meter part? If it's a uniform rod of mass, total mass 10 kg, 5 meter, and if I break it into two pieces, 2 meter, 3 meter, then tell me what is the mass of this and what is the mass.
4 and 6.
So this will be 4 kg and this will be 6 kg, right? So basically, how did you decide this will be 4 kg and this will be 6 kg? By unitary method, right? Right or wrong? You said what, sir? The total mass 10 kg divided by this 5 meter. This was your mass per unit length, and the length of this thing was 2 meter. So you multiplied by 2 meter, right? So can you see, this is how you cancelled it out and you got 4 kg, right? Similarly here also what you did 10 divided by 5 multiplied by 3 or multiplied by 6, right? Yes or no? Are yes or no?
Yes, sir.
So similarly, using the same logic, the mass of the small element will be the total mass divided by the length of the rod multiplied by what is the length of the small element? Are you getting my point? Same logic. Is it the same logic? So this is how.
Yes, sir.
Please write it down. Once you write it down, then just we need to solve this equation. So now from equation 1, du is equals to m by L into dy. This was your Tn. This was your G and this was your y. Can you see m, L and G, they are constant. So they will always be written as together. Whereas y and dy are variable. For different small elements, this y and dy will be different, right? So I have wrote them together. I want what is the total potential energy of the rod. So what will I do? The total potential energy of the rod will be basically integration of this small thing. This m, L and G are constant. They will come out of the integration. And what will remain in the integration? Only y and dy. Now we can integrate it, but for integration we need limits. Right? So can you see, if I have a rod like this and when I was dividing this rod into many small pieces, where was the first element located? Can you see, this was the first element. This was the first element and the height of this first element was 0. And this was the last element on the rod, and the height of this element from the ground is basically equal to the length of the rod. So basically the limits will be from 0 to n. And now when you integrate it, m by L dy. Yes, can anyone tell me what is the integration of y dy? What is the integration of y? Y square by 2. Those who forgot integration, please revise it again. M by L into G. Then I'll put the limits. L square by 2 minus 0. So this will be M G L square by 2. एक कट जाएगा, and finally the answer will be half M. Or we can write it as M G L by 2. Please write it. Once you are done writing, then tell me. Guys, are you done noting down? Give me
Yes,
2 minutes.
sir.
Yes. Yes, guys, are you done? Yeah. So
Yeah.
this was the potential energy. And see, this mg into L by 2 represents something. I told you, whenever things will be uniform, what will you do? You can consider this as for example, this rod was like this. The mass was m, and every element was different. You can consider that this rod of mass m and length l, the whole mass is concentrated here. Are you getting my point? So the potential energy of this rod was half mg into L by 2. So can you see? If you consider this as the center, then this distance will be L by 2 only. And can you see the potential energy of this will be mg into L by 2? Are you getting my point, guys? So you can consider this rod as a point mass, whose mass is located at this, and all the gravity is acting at this point. So this will be the center of gravity of the rod. Are you getting my point? So this is the potential energy. Is this clear? Is this clear? I'll give you one question using this result. Okay. So suppose, Acha, when I was talking about the length of this rod, was there the breadth of the rod involved or the thickness of the rod involved? Was there thickness involved over here in this case? Nowhere, right? So I'm giving you one question. There is a brick, okay, which is initially like this. Let's say this is A, and let's say this is. So there is a brick of mass m and dimensions a and b. After this, what did I do? I इसे करने से ज़्यादा better है. Let me draw it normally. This is the brick. This is A, and this is. So what did I do? I rotated this brick. Control C, Control V, like this. I placed this brick from this to this, such that now it is on A, and this is here. Okay. So now the question is, brick is rotated by 90 degree on a horizontal surface as shown. Find the work done in doing so. Find the work done in doing so. See, we always know now work done by external agent is basically what? Final minus initial. So you just find out the initial potential energy, find out the final potential energy, subtract them. That will be the work done. Okay. What will be the initial potential energy? Can you see this will be acting just as a rod, right? I told you that the thickness doesn't matter. So please know the thickness of a rod doesn't play any role. So initially it is at a by 2 distance and finally it will be at b by. So the initial potential energy is m into g into a by 2 and the final potential energy is m into g. The answer is okay. Done. Guys, are you done noting down?
Yes, sir.
Noting down potential energy stored in a spring. The first we discussed is potential energy, gravitational potential energy. The second which we are discussing is potential energy stored in a spring. Please remember it is a form of elastic potential energy, but it is not. I'm not generalizing it, so you can write it as elastic potential. It is one form of it, elastic potential. Always remember, just like whenever I told you conservative force, right? Conservative forces were those forces which were not dependent upon the path. It was only dependent upon the initial and the final position. The work done didn't depend upon the path, right? So basically, the gravitational force, the spring forces, the electromagnetic forces, all of these are example of what? Conservative forces. So we are talking about this particular force because spring related thing, right? So always remember spring force is a conservative force. Okay. So since spring force is a conservative force, then the work done by the external agent the work done by the external agent. Hello Sania, how are you?
Hello, sir. I'm good.
You forgot about the class?
Yes, sir.
Arey yaar. Well, no problem. I have recorded the lecture, so go through it. Hai na?
Okay, sir.
Since the spring force is a conservative force, then the work done by the external agent is stored in the form of potential energy. So always remember, and that work done is basically called as what? The potential energy of the spring, or potential energy stored in the spring. So always remember, suppose example, you remember spring forces? I had the spring, and let's say initially it is at in its original state, and I start applying an external force. Then what will happen? When I apply an external force, what will happen? The spring will do what? It will extend, right? Yes or no? Suppose if I deform it by a distance, how much? If I deform it by a distance x, then there will be a spring force. Do you remember what was the value of this spring force? Hello? Do you remember what was the value of this spring force? We did questions on spring force. And this Fr was equals to K into X, right? Everyone remembers this? इसी जमाने में पढ़ाया था मैंने, याद है आपको? So suppose if I deform the spring further by a very small distance, can you see very small distance dx? Can you see from here to here I displaced it by a very small distance dx? So what is the deformation now? X plus dx, right? So in this small deformation, there won't be any significant change in the restoring force, right? So I can assume the restoring force as kx, and let me deform it by a very small distance dx. In doing this, the work done by external agent in deforming against the restoring force of the spring. Deforming slowly, especially please remember we need to deform it slowly, otherwise we don't want it to gain kinetic energy, okay? So will be dw. So dw will be equals to f external into dx into cos 0. But we know this thing, if I am doing it slowly, that implies this force and this force will be almost equal, Fr, and this will be equals to what? Kx. So I'll write Kx over here. dw will be equals to Kx dx, and cos 0 will be 1. So now the total work done to deform the spring from its original length. If I say original length, that implies the deformation is how much? The deformation is 0. to a deformation of x naught. So when I deformed it from, this was original length, from here if I deform it to x, then here the potential energy stored will be equals to what? The work done by the external agent, and this will be integration of theta. Okay, here I am taking as a reference, please remember. So the final potential energy will be stored by what? Here. So this will be equals to integration of kx dx. K is a constant, k will be taken out, and the integration will be from x dx from 0 to x naught. This is initial, this is final, and hence this will be the potential energy stored in the string. Let me solve it for you. X dx ka integration will be x square by 2, and when you put the limits, it will be, the final answer will be potential energy. The potential energy at deformation x naught is equals to half a x naught. Please write it, guys, and just give me 2 minutes. One, I'm working now. Yes, people done. Note it down. Hello.
Yes, sir.
Okay.
Yes, sir.
100% again. Chal. So half kx not a square is basically the energy stored. It's not necessarily always on elongation we
Sir, I
get
have
this
a
thing.
doubt.
Ah,
Sir,
bolo,
when
bolo.
will the normal classes start? Like after the vacations?
When will the do you mean the offline classes?
Yes, sir.
Do you mean the offline classes or
Yes,
the
sir. Yes, sir.
offline classes? We are
Sir, the
planning of
offline
September.
classes.
We are planning of September onwards only, but let's wait for 1 or 2 weeks initial September, and then we'll start with the offline because we will take the review again based on the current scenario in Dubai. We will take the feedback. Ki what is the what is
Okay,
the
sir.
expectation of the
And
parents?
September starting, right?
Yes, September starting or first or second week. After first or second week, we'll start. Matlab, classes will be
Okay.
online till first 2 weeks of September. Classes will be online. After that, it will shift to offline or it will remain online. Depends upon whatever feedback is gathered by the parents. समझे?
Okay, sir.
चलिए. So So this is half kx naught square. This is the potential energy stored in the spring. Please remember, note on elongating the spring by a distance x naught from original length, the potential energy stored in the spring will be half kx naught square. Right? We already wrote. Yes or no? If I don't want to elongate it, if I want to compress the spring and compressing also, the potential energy stored in the spring is half kx naught square. So here when we are elongating it by a distance of x naught, then also the potential energy stored in this spring is half kx naught square. And if I want to compress it, then also it is. Okay. Is this clear, guys? The k, the coefficient, the spring constant is not going to change in compressing or this thing, expanding it, elongating it. Acha, by the way, this potential energy stored, kabhi suppose karo, if I release the spring, what will happen? If I keep on pushing the spring, then what will happen? The spring will remain at equilibrium position in this position, right? Or this position, right? If I release this thing, what will happen? If I release this thing, what will happen? Suddenly, this block will start getting kinetic energy, right? Yes or no? Yes or no, guys? So, note this stored potential energy of spring can be used to provide kinetic energy to the block. Please. Is this clear? Next heading. Guys, is spring force clear to everyone? So the relationship between the conservative force and the potential energy in any system, right? Now we know this particular thing, guys, that the potential, the change in the potential energy is basically what? The integration of the work done by external force. Yes or no? Everyone remembers this. That was the definition. So the work done by external agent can be written, suppose you remember lecture, I think second, like I think lecture number three. So I think concluded in the same lecture. Ha! Do you remember this, guys? When we started discussing conservative and non-conservative forces? Hmm. Can you see, guys? Do you remember the work done was integration of f dot dr? We wrote it like this, and dr vector we wrote it like this, and then fr we wrote it like this, and then integrated, right? So the same thing we can do again over here. I think this is our fifth lecture. But anyways, TW external, and this can be written as F external dot dr. Enough? So we can write it like this. But we know this as well. Please remember, in equilibrium conditions, F external is minus of negative of F conservative. I told you, this external force and conservative force will be always equal and opposite to each other, and one will be slightly greater than the other depending upon where you want to shift the object, right? Towards the object, away, towards, ऐसा करके बहुत सारे cases we already gave it. So I can write this F external. I can write this F external as minus of F conservative over here, and from here there will be the last formula which we know. This minus will be taken out, and this will be the conservative force dot the displacement. This is the relation which I was talking about. Can you see the relationship between conservative force and the potential energy of this? Okay, is this clear? So this is one of the relationship. We'll use this relationship later on in the chapter, and basically you will displace it from where to where, from position R1 to position R2, right? X1, X2, Y1, Y2, and so on. Please remember, if F conservative is Fx I cap plus Fy j cap plus Fz k cap, and dr vector is basically dx I cap plus dyj cap plus dzk cap. Then if you are displacing it from R1 vector, which is basically x1 I cap plus y1 j cap plus z1 k cap, from x2 I cap plus y2 k cap plus z2 k cap, and this will be equals to, when you will do the dot product of this thing, it will be fx dx plus fy dy plus fz dz, and you will integrate it from R1 to R2, but R1 R2. Please write it like this. Guys, tell me whether to scroll up or scroll down, okay? But write perfectly whatever I'm writing, because this is also very important as for your school point of view. They will ask questions based on this, and we'll discuss those types of questions. Don't worry. Acha, when is your exams in school, guys?
So probably September or October. They didn't even tell us. They didn't even
They will
tell the
say,
syllabus.
they'll just say surprise that this is coming, right? But as far as I know,
Sorry?
they will just say surprise, and this syllabus is coming. ऐसा कुछ.
Yes. I mean, like, whatever they've done, they'll put that only.
I think ये यहाँ तक आएगा, because they in your school they might have covered till work power energy.
So they are stuck on NLM.
They are still stuck on NL.
Yes, sir.
पीछे है सब बहुत. अपना syllabus अच्छा चल रहा
Yes, sir.
है. What about others?
Yes, sir.
Nikhil, Aman,
So
yeah, Parita.
we just started work, power, and energy and school
We started
course.
work power energy, and we are going to finish work power energy within 2 more classes. Yes. What about Aman and Nikhil?
So we
Yeah. Yeah, Nikhil, tell me.
so we just started work, power, and energy. We hardly had an hour session.
What about you, Aman?
So we're midway through work power energy.
Midway through. Matlab, till here, mostly till here, they will have this much in the syllabus, right? In September, if they have
Yes,
exams.
sir.
So we don't need to take any extra classes and all, because we have covered till the syllabus, right? ठीक. Well,
Yes, sir.
as for now, even as per me as well, the syllabus is going good. Because in last year, what happened, last year we started a little bit late and we were stuck on NLM in this month of August. Still we completed by December. Everything. So my goal is to complete the whole syllabus is during the last week of November. Last week of November, I want everything to be completed till 11, from 11, so that at least I'll have 1 or 2 months for revision. So only I'll make you write the papers and all. We'll have lots of subjective questions practice as well as objective. So, anyways, is this clear? This formula is very important. Dekh lena. this is one of the relationships. The other relationship is this. Basically, this relation will be used when the conservative force will be given and we are asked to find out the potential energy or the work. So whenever we are asked to find out these two things from the force, then we'll be using this thing. We'll be integrating that force with respect to the variable. Similarly, I can do this as well. You remember this delta U is basically dW external. So can I write du is equals to dW external? Can I write it like this? If I integrate it, this du will become u and dW external will become whatever it is, right? So du will become dW external. I can write this thing as minus of F conservative dot dr, right? Yes or no? So I can send this minus to the left hand side. I can send this dr to the left hand. So I can write finally F conservative is nothing but minus of du. This is also one of the relationships. And guys, are you aware of partial differentiation? Guys, are you aware of partial differentiation? If it is having x, y, and z, then take x as constant, y and z. For example, if you're differentiating with respect to x, then take y, z as constant. Did I do this initially somewhere? Hello? Guys, are you aware of partial differentiation? If no, then I can teach you, no problem.
No, sir.
So this is one of the things. First, एक ये लिख लेना रिजल्ट. If we want f conservative as fx I cap plus fy j cap plus fz k cap, and potential energy is given as a function of x comma y comma z. Potential energy is given as a function of x comma y comma z. Then can you see x comma y comma z? What do you mean by x comma y comma z? For example, if I'll give you a question just after this, teaching this concept, I'll give you this question. F is equals to 4x cube plus let's say 3y square z. Okay. So can you see x, y, z, everything mixed in this thing? This potential energies are given as a function of coordinates x, y, and z. Right? So what to do in those cases will be. Okay. So when potential energy is given in this, then to find the conservative force F conservative from potential energy, or you can write from the function of potential energy. We use partial differentiation. What is this partial differentiation thingy? We'll learn by example. Okay. So whatever I'm writing, just write it till now. This is how partial differentiation. This is represented. Suppose whatever energy is there, if I differentiate this energy partially, so I can write this as delta, small delta, delta u by delta x, minus will give me only x component, Just write it like this. I'll tell you what exactly it means. Oh, sorry. Please write it like this. And always remember this is the conservative. So now you understood the relation F conservative and delta U. Basically, can you see over here? If you want to find out potential energy from conservative force, then you will use integration. And if you want to find out conservative force from potential energy, we'll use differential. From potential, we differentiate it partially. Now we'll see how to differentiate partially. Guys, are you done noting now?
Yes.
Okay. In a region, the potential energy is given as a function of what was the function? What was the function? I deleted 4x cube plus 3y square z. Suppose. Can you see there is x also involved, y also involved, and z also involved, and different power is also there. So now the question is find the conservative force of the system. So can you see guys what is given? The potential energy is given as a function of x, y and z, and they are asking what is the conservative force. So what to do in this case, I told you, whenever you want to find out the conservative force from potential energy, we differentiate it partially. In partial differentiation, what do we do? First, we will calculate the x component. When we calculate the x component, which is basically the negative of d delta u by delta x, you know normal differentiation, right? Guys, do you know normal differentiation? In case of normal differentiation, when it was x, we took it as x and we differentiated with respect to x, right? Here we are differentiating with respect to x. So when differentiating with respect to x, assume y and z as constant. And this is how we do the partial differentiation. So basically when I differentiate this thing, it will be minus of delta by delta x of 4x cube plus 3y square z, right? Everyone knows how to perform differentiation, right? The normal differentiation everyone knows. Yes, can you see this function is of x only? So normal differentiate, what is the differentiation of 4x cube? What is the differentiation of 4x cube?
12x square.
12x square plus, and now can you see this is having y and this is having z, right? So y and z we need to assume it as constant. 3 is also a constant, then this whole term is a constant. And what is the differentiation of a constant with respect to x? Are you getting my point? I assumed the y
Yes,
and
sir.
z as constant, so hence this whole term became a constant, and hence the differentiation of a constant term is 0. So this is the x component. After this x component, similarly we'll do the y component. But in case of y component, we'll differentiate it with respect to y. So now differentiate with respect to y and assume x and z as y. So when I do that, it will be minus of delta u by delta y, and this will be 4x cubed plus 3y squared. Now can you see over here? Hello. Can you see this 4x cube will be acting as a constant? 4x cube will be acting as a constant, so differentiation of a constant is 0 plus. Now can you see this is delta y by delta y? I can write it as 3z into y square, right? So I have to assume this whole thing is a constant. So this constant will be taken out of the differentiation, and what is the differentiation of y square? 2y, right? So 2y, this will become 2y. This 2y multiplied by 3z will be 6x, 6yz. Everyone understood what exactly I did? Did everyone understand what did I do? I assumed 3 and z as constant, took them out of differentiation, and differentiated that y square. When I differentiated that y square, what did my y square become? It became 2y. And then I multiplied it with 3z and it became 6yz. So this is my y component of the force. Similarly, what is the z component? You people will calculate and tell me. Minus of delta u by delta z of 4x cube plus 3y square z. Please tell me. Yes, Aman, please tell me what will be the partial differentiation of this with respect to z. Aman,
Yes, sir. So just a minute.
here we are differentiating with respect to z. When we are differentiating with respect to z, x and y will be taken as
Constants.
constant. So this will be
So it will be 0 plus 3y square.
that's the correct answer. Differentiating with respect to z, so assume x and y. So this will be fy fz, and then later on, what will be the final answer? F conservative will be basically what? Fx I cap. So basically, you calculated the different components individual. Yes. Can anyone tell me what was Fx I cap? Achha, I can take minus sign as a common, and this will be 12x square I cap plus 6yz j cap plus 3y square k cap with the minus sign. That will be the answer. Is this clear? Is this clear, guys? It's not necessary every time the R will be given in terms of x, y, and z. Not necessary. Sometimes they might give only two variables, x and y. Sometimes they might give only one variable, x. Then you need to solve how to solve. Okay. So, next question. In a region, the potential energy of a particle is given this much. The mass of the particle is given, let's say 4 kg. Now the question is, find the acceleration of the particle at position 2 comma 4. Chalo, try to do this. I'll just back. Yes, guys. So can you see over here, the potential energy is given as a function of only x, right? So what will be the force? Acha, if I want just the magnitude, what will be the magnitude of the force? It will be du by dx, and this will be equals to what? This will be equals to, find the magnitude of acceleration. I just want the magnitude, no nothing. So this will be, what is the differentiation of this? 5x cube will be 15x square plus 4 plus 0. This will be the force, right? And I'm differentiating what will be the force at, they asked na, find the magnitude of the acceleration at position 2 comma 4. So what will this 4 play a role? Will this 4 play any role? Because see, it's a y coordinate, is potential energy dependent on y coordinate somehow? No, right? So only x coordinate will be playing a role. So the force at x equals to 2, the force will be equals to 15, and in case of x I'll write 2 square, 15 force 64 Newton is basically the force. And hence, if someone asks you what is the acceleration, acceleration will be force divided by mass, it will be 64 divided by mass is 14, and hence that's the answer. Feel right? Yeah. Then, shall I give you one question? As about one or two questions or something similar to this.
Yes, sir. Yes, sir.
In a region, the potential energy is given as 3x square plus 4y square. Okay. Now the question is, the mass of the particle they have not given. Mass is 2 kg. The mass of the particle is 2 kg. And please remember here they have x as well as y. So now I need the vector form. Okay. The mass is 2 kg. Find the magnitude as well as direction of acceleration of particle. Whenever someone asks you acceleration as well as magnitude, so writing in vector form is not enough. You need to calculate the magnitude as well as the direction using the concept of vectors. You know? So found it. At 1 comma, तो 1 comma 1 पे बताना है. चलो, 2 small oral question, मतलब you can, no need to even write those questions. Suppose guys there is there is this path given, okay, and there are 3 points P, Q and R, okay. So the work done in carrying a body from point P to Q is basically 5 joules, and work done from carrying it to Q to R is 2. Now the question is, find the work done carrying from Q to P. And all this is happening in a conservative field. Please take the hint, na? So the work done from P to Q they have given is basically 5 joules. The work done from Q to R they have given how much? 2 joules. Then what is the work done from P to R? They want you to calculate what is the work done from P to R. Arey yaar, it's a conservative field. The work done will be independent of the path, right? So if you go from P to Q, then Q to R, or if you go directly from P to R, the work done should be same, right? It should be independent of path. So the work done from P to R should be equals to the work done from P to Q to R.
Yes, sir.
From take the hint, which is very important. This will be 5 joule plus joule, and the answer will be oral question only. Even if you want to write, no need to write, or नहीं लिखना तो मत लिख, तो लिख. Shall I give you one more oral question?
Yes, sir.
Suppose there is a potential energy in a region is given by 4x square plus 3x minus 5 joules, and they have asked if I want to displace a particle, find the work done by external agent in slowly moving a body from 3 comma 2 to minus 1 comma 4. Please tell me. So basically, what are they asking, sir? This time they are not asking any conservative force or anything. They are asking what is the work done by external agent, and they just have given what is the potential energy. Arey, ये तो और भी simple हो गया. Work done by external agent is nothing but final energy minus initial, right? So if I can just find out this is the final point, this is the initial point. If I can find out the energy at this point, then I can just subtract them and get done. So work done initial will be 4. Can you see this is dependent only on x? I'll just put x over there. 4 into 3 square plus 3 into 3 minus 5. This is the initial energy. And what is the final energy? Final energy is 4 into minus 1 plus 3 into minus 1 minus 1. I think you people can do it now, right? And then, and that's your answer. Okay. So that's it for today. In the next class, we'll be studying something called as work energy theorem. Very important in work power energy, and I'll tell you it's the most important thing in work energy. So in the next class, we'll be starting with work energy theorem next Wednesday. Don't forget. Last Wednesday, I told you, I had a power cut in my area. The light was not there for 2 days. Anyways, tell you guys, thank you very much.